Hello everyone, I'm Gulnara Rahmetullah. I currently teach at Westcliff University, and before that I was part of the Inclusive Interaction Lab at UC Merced, working with Professor Ahmed Sabir Arif. Today I want to talk about something overlooked and yet incredibly common, text selection on smartphones. And this work is titled Predicting Text Selection Time and Effort on Smartphones from Selection Characteristics. Think about how we use our phones every day. We spend significant amount of time entering and interacting with text on these devices. It always starts with trying to select something, whether we are editing a message, copying a link, or formatting a piece of text. However, selection isn't always easy. The screen is small, the handles are tiny, and our fingers aren't really made for this level of accuracy. It frequently requires several attempts just to highlight the right part of the text. And even though we do it all the time, we don't talk about it much. Actually, it's hardly ever studied alone. Selection is viewed as a side effect, with most of the research focusing on typing or fixing errors. However, it isn't. It's a unique task with its own difficulties. And what is more, designing, developing, and evaluating entirely new ways to interact with the text is incredibly slow and resource intensive, especially without a clear understanding of its inherent difficulties. So that's where our motivation truly comes in. We wanted to understand what affects selection performance. We wanted to build models to predict it. And finally, we wanted to use those insights to improve mobile interface design, making it easier and less frustrating for users. Our data builds on the G-Shore study but goes beyond it, including new data from multiple additional unpublished studies. In these studies, participants completed tasks like copying, cutting, and formatting texts. And for each of them, they had to begin by selecting some portion of the text. What made this dataset especially valuable is that the app we used to captured everything. Every tap, every drag, every adjustment. This gave us a robust dataset of 1,330 unique text selection instances, spanning over 2.5 hours of recorded user interaction and capturing a significant 27,739 individual user actions. To really understand mobile text selection, we focused on two key ways to measure performance, which were our main outcomes. The first was selection time. That's simply the total time in seconds from the moment you started selecting until you confirm it, say by tapping copy or cut. The second, and just as important, was selection effort. This tells us how much physical work actually effort went into the selection. It includes every tap, every drag, every adjustment to the selection handles, even the corrections when things didn't go quite right. It's a much closer reflection of what the user actually experienced during the task. So, what did we use to predict performance? We focused on 6 selection characteristics. Our predictors, this fell into 2 categories: length-based factors, the number of characters, the number of words, and how many lines the selection spans. And the second one was distance-based factors, how far the finger moves, horizontally, vertically, and the straight line, like Euclidean distance from the start point to the end. By analyzing these 6 features, we wanted to understand which ones really affect performance and how. Once we defined selection time and effort and the features we'd use to predict them, we looked at how they relate. We started with Spearman correlation to see how each feature like word count or vertical drag related to time and effort individually. This gave us basic sense of patterns. To dig deeper, we used stepwise multiple linear regression. This let us test combinations of features to see how well they could explain variation in the data. Alright, so what did all that data tell us? First, from our correlation analysis, we learned some interesting things. For selection time, we saw weak positive correlations across all our characteristics. Yes, Time does tend to increase as selections get longer or distances grow, but the relationship isn't strong enough to make any single factor a robust predictor. It feels like time is influenced by a lot of other things we didn't measure directly. However, for selection effort, the picture was much clearer. We found moderate positive correlations with text lengths like characters, words, lines, and notably with y distance, which is vertical movement. This suggests that the actual work you put in those actions align much more closely with how much text you're selecting and how much vertical adjustment you need to make. Then we built our prediction models using regression. The contrast was striking. Predicting selection time proved quite challenging. Even our best model could only explain about 6.5% of the variation. It seems highly complex. But when we tried to predict selection effort, we had much greater success. Our most powerful model, which included all six of our characteristics, explained over 21% of the variation. This is a significant finding. Selection effort is significantly easier to predict than time. So, what does this mean for design? Since effort is more predictable than time, that's where we should focus. We can reduce effort through adaptive user interfaces that help before users struggle, especially when vertical movement is high. Something like auto zoom for precision, larger handles, snap to words, haptic feedback, or we could adjust font size and spacing dynamically. These are small tweaks, right? But they can make a big difference, especially for people with motor impairments or anyone trying to select text one handed while multitasking. What's next? We are exploring how everyday things like how you hold your phone affect selection difficulty. We also building smarter models for real world use, and the goal stays always the same. Make text selection easier and more accessible, especially for those with physical or situational challenges. And thank you so much for listening.